Hey, Peicewise Math and History, and we're going to be talking about piecewise functions. So in this video, we're going to take a look at a function. But wait, 3 functions instead. So what we're going to be trying to do is find the function of x in these 3 functions. But there's a question that's everything is up on our mind. And the question is, how do we focus on 3 functions when we only have the function of x for just 1? How do we do that? So your first thought might be,
then you say, we're not talking about this, or this, we're talking about this!
But there is actually a way we can find the function of all of these functions. And that's why we call them piecewise functions. When you're working with piecewise functions, you'll probably see a setup that looks like this. Because since we're trying to find the functions for 3 functions, that is why there's going to be a function right here, another function right here, and another function right here. But when we insert x into, a number in for x, then these functions will turn into equations. On this side, that is telling you what the domain of the functions are, what you get as an inequality for these functions. So let's start doing that. When you are looking for the domain on a line on a graph, what you want to get is an inequality. Because, for example, right here, the U-shaped, that is going to be x squared as a slope. And the line is telling you that any number that's on the line is actually going to work for x squared. And it stops at -2 and starts at a +2. So what we're going to be using is x, because every time we insert a number in for x, that is going to be called our domain, or our input into our equation or function. So what we're going to be seeing here is -2, that represents this dot right here, is going to be less than or equal to x, and we have +2 right here, so it goes from here and stops right here. So that's telling us that it can also be less than or equal to 2. So when you're looking for the domain of a line on a graph, you will want it as an inequality, because the numbers on the line are actually answers for the slope as well. So what we're going to put for x squared, and -2 is less than or equal to x, and is less than or equal to 2, we're going to put that in here. So we have -2 is less than or equal to x, is going to be less than or equal to 2. And our slope for that U-shape is going to be x squared. So we have first put our function on here. We're going to add 2 more, since we have 1 right here and 1 right here. Let's take a look at the green function. So when we take a look at the green function, it's telling us that right here is going to be our starting point, and it's telling us to go this way. X is going to represent numbers that are in a line going this way. So what we're going to get is an equation as x is going to be greater than 2, because 2 is going to be our domain. And when we have x, it's telling us that x is going to be greater or equal to 2. The reason why is it's a shaded dot. That's saying that this right here can be included and can also be going in this direction. Any numbers on here will work. So, since we have x is going to be greater or equal to 2, we're going to find the slope of this line right here. And this line actually comes from an actual problem on a worksheet. And it states that the slope is negative x plus 6. You'll be able to find the slope of the line if the numbers were appearing on the graph. So we're going to put negative x plus 6 as our slope intercept form. Let's see what the blue line is, and then we'll be able to find what the function does to all three of them. So, with the blue line, we have an open bubble, and it's saying that negative 2. So we're going to say that x is going to be this line with all the numbers going down. But actually, when you're using a line on a graph, they always should be going from left, and their destination should be pointing towards right. So instead of this going down, it's actually going to go up. So what we're going to say is we're going to have an inequality of x is going to be less than negative 2. Because negative 2 is right here, and x is all these numbers lined up together in a line. But they're less than negative 2. And since it's skyrocketing up, it's going to be called a positive slope. According to the problem on the worksheet, it says that it's 2x plus 1 is the slope for this blue line right here. So we're going to put that right here. 2x plus 1, and the inequality x is going to be less than negative 2. So we now have all the functions in these squiggly lines, and we're going to insert a number in for x. But wait, there's some rules that we have to follow. Before people know what the rule is, many people might obsessively start adding any number in for x. Like x is going to be like 1,000,000. Or x is going to be negative 10, or x is going to be 0, or x is going to be 7, or 8, or 7, or 9, or... You gotta actually follow the rules. So the inequality are actually going to state what numbers can be fitted in for x. And when the number works in the inequality, then you're going to be allowed to put it in your slopes of what the functions on the graph were, and you'll be able to find what f of x is. Piecewise functions actually limit and restrict what you can insert in that giant x. So let's do a sample problem. Find the function of negative 4, and we're also going to insert them in these. But wait, negative 4 has to pass some of the tests that are in here. What we're going to say is negative 4 is inserted in for x, is negative 4 greater or equal to negative 2? And is negative 4 less than or equal to 2? Well, negative 4 is not more than negative 2. So this is not going to work. And negative 4 is less than or equal to 2, but it doesn't follow negative 2 is less than negative 4. That's not going to work. So, the x squared is not going to work. Let's try the other ones. Is negative 4 inserted in for x going to be greater or equal to 2? Nope, definitely not either. Negative 4 is not more than 2. So the negative x plus 6 is not going to work. Number 3 is negative 4 less than negative 2? Yes, and hooray! So when we have a number that follows one of the rules, what we're going to be doing is we're going to be inserting -4 into 2x plus 1 because that was the slope for the blue line on this worksheet, and that is the slope of this line on the graph. So let's insert -4 in for x since we got the approval by the inequalities. So 2 multiplied by -4 is going to be -8, plus 1 is going to be -7. So if you insert -4 in for the formula for right here for slope-intercept form, you will get an answer of -7. So piecewise functions actually limit what you can insert in for x. And when you come up with a number, like 6 for example, don't assume that nothing is going to work. What you want to do is see if 6, as an example, works for the inequalities. If this one fails, then don't use it. If this one works, then yes, definitely use it. And it gives you the approval to put it in for x and drive you to your answer. Piecewise functions are basically the switch tracks on train tracks in mathematics, because when you're on the main track right here, f of x, and if you want to find out what 6 goes into, then the whole idea of piecewise functions is going to say, switch to this track, or this track. 2 of the tracks is not going to work. 1 of the tracks is going to get you to your station. And when you do that, it'll drive you to your answer.
Hold hands, but please remain in your columns while we are in transit.
And that's how piecewise functions work. I hope this video has helped you. Thank you for watching Tao Penalized Math Industry. Like and subscribe.